Hi, I'm Primary 6 from YUMIN Primary School. For this time we are still at ordinary differential equations. By ordinary differential equations, past lessons, we have always been using characteristic equations. Well, for that homogeneous part, characteristic equations, we have always been using it. Okay, so how about the general form of those examples that we have done? Those examples that we have done, what are the general form? Okay, so let me just write this out. So for their general form, it will be like this. Okay, let's see. This general form, at this side, what do you see on this side? Well, there's this y, and y is what we want to get. Then y ith derivative, that means we don't know how many times they differentiate. You can keep on differentiating them. Okay, so, but let me just tell you why. We're not just finding a number, but we are actually finding a function of x. Okay, so this is the y. But for this ai, it's just a constant coefficient of this y, whatever derivative. And in front here, this sigma is just to add all those things together. But this constant, it might be positive, might be negative. Well, it varies, just that it's constant. Then at this part, so that means it is y, whatever derivative, then times just a constant coefficient, then add others. Wait, isn't that meaning that this is actually linear? Yes, that means this is linear. And wait, linear, what is its actual meaning? Okay, so actually, if you want to say it is actually linear, then that means you'll have to be, you can explain it as it's just y and all the other derivatives of y. Between them, there are no operations, only this derivative times a constant coefficient, then plus or minus others. In between these two, like for example, first derivative, second derivative, there are no other operations. Like, they cannot be stacking on one another. They cannot be multiplication. They cannot be division. Just times a coefficient, plus or minus. Then times another coefficient, just like that. So that means it is linear. Qx. Now Qx there are two cases. Qx first case, 0. If Qx is 0, then this whole thing will just be a homogeneous ordinary differential equation. If it is not 0, then that means it is non-homogeneous. Okay, if it is non-homogeneous, and you want to find the general solution. So it is yg, and this will be yh plus yp. Yh and yp. Now what's so special? Yg is what we want to find, and yg is also the general solution for this non-homogeneous ordinary differential equation. Yh. Now yh, this is the general solution for a homogeneous ordinary differential equation. And yp will be the particular solution for a non-homogeneous ordinary differential equation. Yh. What kind of method do we use? Well, yh we use characteristic equations. Yp. Now yp. Well, substitution. or coefficient comparison. So that is what we have for here. So these two just adds up and gives you YG. So this is its channel form. But for this, we still need a lot of examples to show us different methods. Okay, like for example, okay, so this example that we have here. In this example, it is 3 y prime prime minus 5y prime minus 4y. And this will be, okay, this fraction is really long. Sine 4x minus sine 3x minus sine 2x plus sine x. Then break it together times cosine x. Then for the denominator, cosine 4x minus cosine 3x plus cosine 2x minus cosine x. At this part, look at this long fraction. Of course, it is non-homogeneous. This linear, constant coefficients. Okay, that means it will still be in the form YG, that is YH plus YP. This is the form. Next part. We first try to find YH, but this long fraction, we first ignore it. And just let that part be 0. Okay, this is what you have. But for this part, characteristics equations, you get 3 lambda squared minus 5 lambda minus 4. This will give you 0. But in the past, we might have used factor theorem for this. But according to factor theorem, but if you try, you might not be able to get it. How about you try something else? Cross multiplication? I don't think so. So at this part, there is something else that we will need to use. The quadratic formula. But since this is a square, so that means there have to be 2 roots. So with these 2 roots, so the quadratic formula, negative b, in this case will be 5, plus minus square root b squared minus 4ac. So minus 4ac. Okay, let's see. Wait, but be careful, here is already a negative. So that means negative, negative, positive. There, this will be over 6. Okay, now these are your 2 roots. So lambda 1, you can say that it is plus. But inside here, 73. Then lambda 2, you can say that it is the minus. Okay, this is what you get. Next part, just find YH. To get this part, wait, let me just write this clear up. Like this. Now this is your YH. Next is your YP. But YP, be careful. This part, if you just let this whole thing, then wouldn't it be too complicated? So let's try to simplify things. Well, according to here, these two parts, maybe let's try to put them together. Well, you can say that this is sum to product, or the factor formulae. The sum to product formulae. But let me write this whole chain down first. This is what you get. The sum to product formulae. Sum to product. For example, here you are using sine alpha minus sine beta. Then this will be 2. So this is cosine. So let me use cosine. Alpha plus beta over 2. The other is sine alpha minus beta over 2. That's the first part. So in this case, add together, then divided by 2 will be 7 over 2. Then sine here will be x over 2. Then over here you can try to use it again. But for this part, I'm sure that it's a negative, because if here's a negative, here's add, then after that, sine, there will be another negative. So that means this is gonna be a negative. So let's check. This is still the same form. Wait a second. For this part below, although we are still using a sum to product formula, or also known as a factor formula, but it's a bit different. So for this part, what we are using will be for cosine. Wait. But cosine and cosine, that means this part is gonna be a negative. So for this part, write it here. And that means both will be sine. Okay, like this. Then we might want to simplify things a bit. For example, 2, we can simplify. Then sine x over 2 also can be simplified. And this negative, we might want to take it out. Well, you can write this on the numerator, this x. Wait, for this part, don't have. So that means it'll be like this. Then this negative, then inside this part equals this. Sine and sine, and if there is a plus, that means it will be sine cosine. So this part you have another negative. So cancel out. So these two add 5x over 2. Then over here, when you minus 4 over 2, that means the 2. But then you have to divide by another 2. So it's x. So that means this denominator you get like this. And all that's left will be a sine x. Left with a sine x, now that's extra simple. That means this whole thing is just a sine x. It's just like this. Next part, let. The other is just to calculate these out. Let. Well, since here you only have a sine, then that means you just change it to sine and cosine. The answer is just find first derivative and second derivative. Okay, just like this. Sum them all back, but regroup at the same time. So that means it is just like this. On there are just two equations and we are done. Then you can just call this equation number 1, equation number 2. Okay? Yep. Equation number 1 times, well, what can you have? Times 7. Then add on to equation number 2 times 5. What do you get here? So here is negative 48 and here's a negative 25. So it would be a negative 73a and this is 7. So A would be, wait a second, this is 74. So A will be a negative 7 over 74. Then B, you just sub it into any one of them. For example, you can sub it inside here. So it will be 48 over 74. I mean 49 over 74. Change it to the other side. And then just divide. So that means this part will be a 5 over 74. Okay, A and B found out. Then that means YP will just be, okay, so this is like negative 7 over 74 sin x plus 5 over 74 cosine x. Then final step is just to find YG. YG, just these 2 points add together. Wait. So like this, and you're done. All this part, if you want to verify, then you go ahead and verify on your own. But for this part, I think I can end here. So overall, for this part, the most interesting part is actually this fraction. You just simplify and continue to simplify, then you just get a sin x. Oh, that is quite weird. Okay, so for this lesson, I'll end it here. So if you like our videos, don't forget to subscribe to our channel. We'll see you in the next lesson. Thank you for watching.